This training video supports states and tribes conducting diatom sampling as part of the U.S. EPA Region 5 Diatom project. The video describes the methods that the Indiana Department of Environmental Management uses to collect diatom samples from rivers for determining the relative health of water bodies. What are diatoms? Diatoms are single-celled microscopic algae with hard outer shells that live in the water on the surfaces of rocks, sticks, plants, and other materials. Like other aquatic communities used in monitoring programs such as fishes and insects, the number and kinds of diatoms found in a river or stream provide information on the health of the stream and clues about water quality. To start your field efforts, you will need the following equipment: a large tray for holding rocks or sticks, a dissecting probe, a flat blade knife, a 1,000 milliliter graduated cylinder, a stiff bristle brush, tap water in a wash bottle, two 250 milliliter sample bottles, loppers and pruners for cutting stick samples, a toothbrush, fabric measuring tape, and finally, an SG92 assembled beforehand. The SG92 is a modified syringe that is used to outline a defined area on a cobble for scraping algae. Multiple SG92s should be assembled prior to going into the field. To assemble the SG92, first cut off the tip end of a 30 milliliter syringe barrel opposite the syringe flanges. Sand the cut end of the barrel smooth. Flatten one side of a rubber O-ring using emery cloth. The O-ring should have an inside diameter of 2.06 centimeters and an outside diameter of 2.7 centimeters. Cement the flattened side of the O-ring to the flanged end of the syringe barrel using cyanoacrylate adhesive. Now let's discuss preparation for sampling. Note first that sampling should be conducted outside of the influence of precipitation events. In the case of a rain event, diatom sampling may need to be postponed for at least 2 weeks to allow time for the community to recolonize after high flow events that may scour the stream substrate. Conduct normal pre-sampling preparation at the site. Prepare appropriate bottles for water chemistry and diatom sampling with descriptive labels. Prepare field data sheets. Gather other necessary equipment for diatom sampling and any additional equipment needed for water quality sampling, such as sondes. Take water chemistry samples including nutrients and other parameters, water quality probe measurements, and canopy cover estimates before sampling the diatom community. Take care not to disturb any substrate that will be sampled for diatoms. Recommended water quality parameters for this project include air and water temperature, dissolved oxygen, conductivity, pH, total phosphorus, orthophosphate or soluble reactive phosphorus, nitrate, nitrite, nitrogen, total Kjeldahl nitrogen, total suspended solids, turbidity, and benthic chlorophyll A. Dissolved phosphorus, total suspended solids, and benthic chlorophyll A may be eliminated to lower costs or effort. Total phosphorus, nitrate, nitrite, nitrogen, and total Kjeldahl nitrogen should be analyzed at a minimum to evaluate nutrient relationships with the diatom indices. Also measure canopy cover and any normal habitat parameters. Evaluate the sampling reach to determine what type of diatom sample will be collected: epilithic rocky substrate or epidendric woody substrate. Rocky substrates in shallow riffle areas are preferred when available. Target woody snags if the stream is dominated by small-grained substrate. Collect 10 submerged rocks from a transect across the stream in a line from the center of the reach in rocky substrate areas. Put these into the large tray. Choose undisturbed rocks that have not been exposed for best results. Do not pick rocks larger than your hand. Rocks should also have a relatively flat surface that has a visible biofilm coating it. Rocks should have sufficient surface area to allow for 2 placements of the SG92. Rocks may be collected about 20 to 25 meters from either side of the site transect if necessary in order to select appropriate substrate. Rarely, you may need to move to the next riffle area to find suitable substrate, up to 50 meters from the original site. The area from which rocks are selected should be of similar conditions and representative of the main site. When all 10 rocks have been collected, randomly select 5 rocks and return those to the stream. Begin the sample process on the rocks. Take one rock and place the SG92 O-ring side down on a flat part of the top surface of the rock. Be sure to choose a spot on the rock that allows a second SG92 placement and scraping next to the first. With the SG92 held against the rock, insert the dissecting probe into the open top of the SG92. Scribe the inside circumference of the SG92. Remove the SG92 and scrape away algae from the circle with the flat chisel blade. Only scrape algae from within the scribed circle, which provides a known area for calculating biomass of diatoms. Place the removed algae directly into the 1000 milliliter graduated cylinder and then use a stiff bristle brush to remove any remaining paraphyton from the scribed circle on the rock. Rinse any remaining paraphyton from rocks and tools with tap water into the graduated cylinder. Repeat this process on a second SG92 circle on the same rock. Repeat the same process of sampling 2 SG92 circles on each of the 5 rocks, creating one composite sample of 10 scrapings in the 1000 milliliter cylinder. Use tap water to dilute the slurry to 400 milliliters after 2 scrapings from each of the 5 rocks are in the 1000 milliliter graduated cylinder. Homogenize the sample by swirling the graduated cylinder and place 200 milliliters of the slurry into a 250 milliliter sampling bottle. A contractor laboratory will use this sample for diatom identification and counting. Place 50 milliliters of the slurry into another sample bottle. EPA's Office of Research and Development Laboratory in Cincinnati will use this sample to analyze environmental DNA. Put the sample bottles on ice and out of sunlight, and freeze when you return to the office or lab. If chlorophyll A is being analyzed from the sample, place 200 milliliters of the slurry into a 250 milliliter sample bottle for diatom identification, 150 milliliters of the slurry into a 250 milliliter sample bottle for benthic chlorophyll A analysis, and 50 milliliters of the slurry into another bottle for eDNA analysis. Ensure that at least a 150 milliliter diatom enumeration sample and a 50 milliliter eDNA sample are taken from the composite 400 milliliter slurry, even if your agency has another established process. Submerged sticks may represent the most stable substrate to sample diatoms, if the site is dominated by soft substrates. Use loppers to cut 5 submerged sticks as close to the center of the reach as possible and place into a tray. Sample only undisturbed sticks with visible algae and without major irregularities. These sticks should be between 7 and 20 centimeters long and only slightly larger than a finger's thickness to allow for efficient cutting. Hold the sticks over the tray, scrub algae from the sticks with the toothbrush into the tray, and rinse sticks with the tap water between scrubbings. Scrubbing should be hard enough to remove algae, but not so hard as to remove bark. Repeat until all algae has been removed from the 5 sticks. Use tap water to rinse any algae remaining on the toothbrush or gloves into the tray. Pour the slurry from the tray into a clean 1000 milliliter graduated cylinder, using tap water to dilute the slurry in the graduated cylinder to 400 milliliters. Homogenize the sample by swirling the graduated cylinder and place 200 milliliters of the slurry into a 250 milliliter sample bottle for diatom identification. Add 50 milliliters of the slurry into another sample bottle for environmental DNA analysis. Put the sample bottles on ice and out of sunlight and freeze when you return to the office or laboratory. The surface area of the stick needs to be calculated. Measure the length and circumference at each end and the middle of each stick with fabric measuring tape and record these measurements. Calculate the lateral surface area of each stick using the formula shown that assumes the shape is a cylinder. Diatom sample identification and eDNA samples should be frozen after sampling. Identification samples will be sent to a subcontractor. eDNA samples will be shipped to the EPA Office of Research and Development Laboratory in Cincinnati. Shipping information for the samples will be provided for project participants prior to the field season. Thank you for watching this training video for diatom sampling for the Region 5 Diatom project.